It's so close to us, at least in terms of space, but there's still so much we don't know about the moon yet. For example, Chinese researchers have collected soil samples from the moon and found out there might be billions of tiny glass spheres on the lunar surface. What's really cool is that they might hold enormous amounts of water. These tiny spheres form when meteorites hit the moon at crazy speeds, sometimes at hundreds of thousands of miles per hour. When that happens, a strong explosion sends bits of the moon's crust flying into the air like popcorn. As these chunks of crust cool down, they create little glass beads that look like tiny glittering spheres. These beads are so small that they're like crumbs sprinkled over the moon's surface. Scientists call them impact glass. And it turns out the soil on the moon is holding a secret ingredient that can make water: oxygen. So, these tiny glass balls are like little capsules with oxygen inside. There's a special type of wind called solar wind, and it's made of protons and electrons. When protons hit the capsules, they mix with the oxygen inside and finally make water. But the most amazing part is that some of these glass balls with water inside get hidden under a layer of the moon's dust called regolith. So if we go on a mission to the moon, we'll have hidden reservoirs of water underground. It's as if someone has prepared some canned food for us to survive. Because you can't drink that water directly from these glass beads, you're supposed to collect them and then boil them in an oven to extract the water. When they cool, they release vapor, so you'll have regular liquid water in a bottle. That way, astronauts on their missions will be able to stay longer up there, considering these secret stashes. And the coolest thing is that these glass beads are very common on the moon. They're spread from the poles to the equator, which means there might be enough water even for generations that might come to live there one day. There are other spots where we can find water in space too. For example, scientists found an extremely big cloud of water vapor that's 12 billion light years away from us. Not within reach, of course, but it's still good to know. And we're talking about something bigger than we can imagine. It's thought the cloud contains at least 140 trillion times the amount of water in all the oceans and seas on our home planet. Imagine swimming or scuba diving there. It's like taking a dip in a giant water balloon that's traveling through space. I mean, you wouldn't have a way out considering the amount of water in there, but hey, at least the view would be magnificent. Water is actually everywhere across our solar system. It's mostly in the shape of atmospheric gas or ice, and sometimes even in its liquid form. And there are probably many water worlds in our galaxy too. Scientists from the University of Copenhagen have discovered exciting new evidence about how planets form in our solar system and beyond. Their computer models have confirmed the interesting theory of pebble accretion, which means that planets form from tiny pieces of ice and dust. This theory is based on the observation of disks around young stars that are made up of pebbles that come in several hundred Earth masses. As these pebbles collide and clump together, they form protoplanets and, eventually, planets. What's even more exciting is water could be an important ingredient in this planet's making. It also means that the water may not have come to Earth by chance, for instance, via icy comets hitting our home planet. Instead, maybe it was there from the very beginning. Perhaps planets in our neighborhood, like Mars and Venus, formed with water as well. Scientists also say we shouldn't assume we're a special case just because we have water. There could be many planets all over our Milky Way galaxy as big as Earth that have water too. That means there could be many worlds in our galaxy with continents and oceans, which could also mean there is a great deal of life out there waiting to be discovered. But just because there's water somewhere, it doesn't mean that place would be a good spot for an interstellar summer vacation for future generations. Water on many planets is probably embedded in rock or fills underground oceans. Researchers have checked more than 40 exoplanets we know about. They're all smaller than Neptune and located around something we call red dwarf stars. These make up 80% of all stars we're familiar with in our galaxy. They're cooler than our Sun and also the smallest type of hydrogen-burning stars. And there could be more planets with enormous amounts of water than we thought. Plus, this water can take up to half of the total mass of these planets. Scientists know this because they've been studying the density of these exoplanets. They have realized they're too light to be made entirely out of rock. I've mentioned Venus before. Today, it's a hot, rocky planet a bit smaller than Earth, with a dry atmosphere and only some traces of water vapor. It's also very poor in oxygen. But in its early stages, the planet may have been a completely different world with liquid water and even clouds, which means it's possible there used to be life. What if Venus used to be similar to Earth, with oceans and moderate temperatures? It would be great if it stayed that way, because these seem like good conditions to develop life, so we'd probably be writing letters to some of our space friends from there, or visiting them already. But the scenario went in a different direction for Venus about 700 million years ago or so. The planet got so hot it lost all of its oxygen. That's why it wasn't able to form liquid water on its surface. Instead, it developed a thick atmosphere made up of carbon dioxide, which made this world even hotter than Mercury, even though it's twice as far from the Sun. Even icy comets pelting it couldn't bring water back to its surface. We can't do it either in some artificial way. It would be like trying to grow a delicate flower in a desert. No matter how much you water it, if the conditions are too dry and harsh, the flower won't survive. But some people thought the water in the atmosphere of our close neighbor could be enough for developing life. Plus, scientists have discovered there is a compound called phosphine that's often associated with living organisms on Earth. Maybe in the past this was enough. Today, the amount of water on Venus is so small, even our toughest microbes that are extremely tolerant to droughts wouldn't be able to stay alive there. Phosphine is still a cool discovery worth investigating, but not something that tells us there could be life on Venus. Jupiter might be a more likely option for that. The Galileo probe flew through the atmosphere of this magnificent gas giant to measure the temperature and water activity. It found out there was enough water for life to exist in the planet's clouds, but sadly, there are not enough nutrients there. Plus, there's too much ultraviolet radiation, so most organisms wouldn't actually be able to survive there. And everyone knows Europa, one of Jupiter's moons. It's that very place in our solar system that has the biggest chances to support life. Its icy crust probably hides an ocean underneath. And because of Jupiter's gravity that affects Europa, the ocean is not frozen, but remains liquid. The ocean might be warm under that icy crust, probably thanks to hydrothermal vents. Enceladus, one of Saturn's moons, probably has even higher chances to host life than Europa. And it's one of the best candidates to have a beautiful, warm, and salty ocean beneath the surface. It has the coolest ice geysers that catapult into space about 1,000 tons of water every hour, together with salt, organic molecules, and some other materials.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.